Hello and welcome back once again. In this section, we are going to cover cloud database services. And the learning objective of this video, we are going to start with overview of GCP database services. After that, we'll move to what is Cloud SQL. We'll learn about it. Then Cloud BigTable, the Cloud Spanner, Cloud Memorystore, and we will have a demo on provisioning MySQL database instance onto GCP. And finally, we will move to the use case of database services. So without wasting much time, let's get started. So the overview of GCP database services. Like in the other sections, we talked about compute services, network services, identity and access management, right? And when we talk about GCP database services, it is also one of the critical component of any cloud provider, right? So what does GCP database services has to offer? We will look at here. So GCP offers you managed relational and NoSQL database services. All right. So the businesses which are traditional web or line of business that may use the RDBMS, that is relational database services, and it is provided by GCP database services. And as you know that the IT industry is adopting new changes, and one of them is they are switching to NoSQL databases. And this we call as a modern application that is very well supported by GCP database services. Web scale distributed applications need multi-region databases. This is required for the better availability and faster processing, right? This is also taken care by GCP database services. Okay, and finally there is a in-memory database is used for accelerating the performance of application. So this in-memory database comes into picture just for increasing the performance by using the cache mechanism and other mechanisms. You can very well accelerate the performance of your applications. All right. So now let's try to understand about Google Cloud SQL. So it's a fully managed RDBMS service that simplifies set up, maintain, manage and administer database instances. It means that you don't have to launch a virtual machine and you don't have to install any database physically into it. It is a managed service, which means that by click of a button, you will be able to launch a cluster of Cloud SQL and that will be fully functional. You don't have to designate dedicated database administrator. It is all taken care by Google. So the Cloud SQL supports three type of RDBMS, that is MySQL, PostgreSQL, and Microsoft SQL Server. All right. So it's a managed alternative to running RDBMS in VMs. In a typical application, what happens? You designate a VM, and in that VM you install a database server, and that is managed by some DB administrator, right? Cloud SQL delivers scalability, availability, security, and reliability of the database instance. So as discussed earlier, everything that is see here is fully managed by GCP. You don't have to worry about the scalability, availability, security, and reliability of the database instance. Okay. Now you can also launch of the SQL instance in a virtual private cloud for additional security. So if you don't want to expose your SQL to the front end facing applications, you can just launch up a VPC and you can launch up a Cloud SQL instance there and expose your all the backend applications to access the data from that Cloud SQL, and that will add some additional security to your applications, right? So that's all about Cloud SQL. Now after Cloud SQL, it's time for us to learn about Cloud Bigtable. So it's a petabyte scale managed NoSQL database service. So what's petabyte? You can imagine 1 petabyte is equal to 1000 TB of data. That is way too much, right? So it is sparsely populated table that can scale up to billions of rows and thousands of columns. So you can imagine the size of the table. You cannot even think of a manual activity that you can do on that thousands of rows and columns, right? It's the big table that offers you table that can scale up to billions of rows and thousands of columns. So that's how the name comes, big table. Now it also acts as a storage engine for large scale and low latency application. So large scale and low latency, that is one of the very common requirement nowadays for any enterprise application. nobody wants lag in their application, so they are going for BigTable. Now it's ideal for throughput intensive data processing and analytics, right? Wherever there is a high read and write operations, in that cases this BigTable is very much useful. Now it's an alternative for running Apache H-based column-oriented database in VMs. Apache HBase is one of the tables similarly to BigTable only, but it is launched up in a VM. It can also have very large number of rows and columns, right? So you can use this BigTable as the managed alternative to Apache HBase column-oriented database. All right. Now it acts as an storage engine for map reduce operations, stream processing, and machine learning applications. So as you know, machine learning requires a very huge amount of data for the machine to analyze and learn from it, right? You can imagine this can only be achieved by using the big table. All right. So now it's time for us to learn about Cloud Spanner. And this is one of the GCP's very differentiating service from other cloud providers because it has lots to offer to its users. So it's a managed, scalable service for regional and global application data. Okay, it scales horizontally across rows, regions, and continents. All right, and it brings best of relational database and NoSQL database. So relational database here is known for its high scalability. Wherever you want to scale a relational database, you add more CPUs to it to get more better throughput, right? And the NoSQL database is based on nodes. If you want to scale up a NoSQL database, you add more nodes to the database. It's all NoSQL database is also known for better synchronization so that the data will be consistent across all its instances, right? So the Cloud Spanner brings best of relational and NoSQL databases. Okay. Now it also supports AC transactions and NC SQL queries. So in terms of microservices, nowadays ACID transaction is one of the requirement of every application, that is atomicity, consistency, isolation and durability, right? So all these are supported by Cloud Spanner and it also supports SQL queries. All right. So data is replicated synchronously with globally strong consistency. So you can launch up a different instance in different continents, maybe Asia, Europe, America, right? And data will be synchronized or replicated across all its instances in a very consistent way. Okay. And Cloud Spanner instance run in one of the three region types. Okay. So it's a read write or read only or witness. That means that there is a dedicated region that supports only read write operations, and there is a region that supports only read operations, and that will basically increase the throughput of the application because it is not having any write operation. So no, there is no any hold on the thread. That region is only dedicated for read only operations, right? And there is a witness. That means that across all these regions there will be one region that will be dedicated for synchronizing the data within all its instances. Okay, that means that it will maintain all the nodes of the application healthy and data will be synced in the real time. Okay, so that's all about the Cloud Spanner. So now let's have a look at Cloud Memory Store. It's a fully managed in-memory data store service that is based on a Redis. So what's a Redis? Redis is nothing but a kind of a database that acts as a in-memory in any application. Okay, so it's based on Redis. And you know what? When you have an application that is having very frequent call to the database, in that cases, you can use this kind of memory store service where you don't have to hit the database again and again for getting the same data. It will be cached in the memory. Every time you go with the same query, the data set will be returned from the in memory, right? So ideal for application cache that provides sub millisecond data access. All right. Now cloud memory can support instances up to 300 GB and a network throughput of 12 Gbps. Okay. So if you see a typical application, it will be having a database and there will be front end of the application, right? So this is a DB and this is your front end application. And suppose if you want to query this DB frequently, you will every time go to hit this database. That will increase the cost of querying the database. Also, it will reduce the performance of your application, right? So Cloud Memory Store says that we offer you a 300 GB of cache. So what it does, the first time when you go to fetch the data from this DB, it will store the data in the cache and it will give the response to the front end. So for the next time, if you are querying with the same query, it will not go to the database, it will go to the cache and it will check if there is a result set that is already available in this cache and return it to the application. So you don't have to hit the database again and again. So the cache will act as a database for serving you the data, right? And it can store up to 300 GB, that is way too much of space, and 1200 Gbps of throughput. That means that it won't even take a milliseconds of time to get you with the data. Now it's a fully compatible with Redis protocol. It means that if you have an application that is already having a Redis in-memory cache installed, there will not be any code changes for integrating that application with the memory store. Okay. Now it promises 99.9% availability with automatic failover. Means that you don't have to worry about losing your data, and in case where this in-cache memory stops performing, you always have option to go to the DB and again get the data and store into cache. Alright. Now it's integrated with stack driver for monitoring. That means that you can, any error that is happening in the memory store, you can easily monitor and report that error or fix that error, right? So that's all about memory store. Now it's time for us to start with the demo. So in this demo, we are going to start with provisioning of a MySQL database on the GCP. So as usual, I'm on my GCP console, and in the search bar, I will type SQL. I will get some results. In that, I have to select this SQL and we will go to SQL dashboard. Now in here, if you don't have any instance created here, it will be blank and you can go and create a new instance. So click on create instance and you will get the option to choose your database engine. So it offers MySQL, PostgreSQL and SQL servers, right? So we are going to start with MySQL and we can now go ahead and start creating our instance. The instance ID, basically it is the instance name. Basically it is the name of the database that you want to give, and it should be a logical name that you cannot change it later. In this case I am giving it demo SQL1. It should be lowercase letter, number, hyphens, starts with a letter. Okay. And the next thing is the password. We can leave the password as blank, but it is a good idea to generate a password. So I will click on generate. This will generate a password for me. Let me visualize the password and I will copy this password and keep it in a safe place. Alright, so our password is created. Now we have to select the version of the SQL that we want. I will go with 5.7. You can go with any of the latest version. I will go with 5.7. After that, choose regional and zonal availability. So for better performance, you can keep the data close to your service that need it. Okay, so region is permanent while zone can be changed anytime. So these all things you have to keep in mind. I want to keep it in a region which is nearer to me. Let me keep it Mumbai, Asia South 1, and you can select the zonal capability. So I want to keep it multiple zone, and you can select a primary zone and the secondary zone. So I will keep it any for now so that it can automatically select the best zone which is available to me. After that, you can customize your instance. So let's go through the customization once. As we were getting the option of choosing the machine type in compute engine, we get the option to choose the machine type here as well. It depends on your requirement what kind of machine you want. You can keep it lightweight, standard, high memory. Let me keep it high memory, and 4 CPUs and 26 GB of space I have selected. You can select as per your requirement. Now the storage is SSD that is recommended. I am not changing any settings in here. I'm just going to select this 10 GB because I'm just using it for demo purpose. So I'll keep it 10 GB. Now the connection, you can select the public IP and the private IP depending on the requirement. If we are selecting the public IP, that means our IP is open to the internet and anybody having the credentials can access the DB. You can select the private as well, but I will keep it public. Now the backups you can select to be automatic. It's always a good idea to select the backups. When do you want to back up your data, every weekly or what is the time, so that you don't lose your valuable data. It's always a good idea. Next is the maintenance. So maintenance activity is one of the important activity that takes place every few months, and you should always choose a maintenance window when you predict your traffic is very low. And you can also set the flag in here. I will keep it to default. Labels, basically you can add some more metadata in the labels. And that's about all the customization. And after that I have to click on this create instance and it will start creating the instance. It takes around 7 to 8 minutes for creating one database instance. I have already created it. I will not create it again. So let's go and see my database instance. So the one I showed in the beginning, this demo SQL, this is the instance that I have created and it is hosted in Asia South 1. All the configurations that we did, it's same configuration we have launched. We were able to successfully launch up this database instance. Okay, now let's start up this instance in our command line. So let me use the Cloud Shell and the Cloud Shell is being launched. Okay, so the Cloud Shell is launched. Now I will just type gcloud SQL connect the database name, the demo SQL. Basically this will whitelist your IP for incoming connection just for 5 minutes. Generally we don't use the Cloud Shell for interacting with this database. This Cloud Shell can be used for the maintenance activities. So it is just activating it for 5 minutes. Okay. So after whitelisting your IP, it will ask you for the password. So in the beginning I mentioned to copy the password. It's time to paste your password in here. So I have entered the password and now we are into our MySQL database. You can perform any kind of queries now, like create database tables, or all those queries that you want to perform, you can perform from here. So that was a very comprehensive demo on creating a MySQL DB instance, right? So that's it for the demo. Let's move to our other section, that is the use case of database services. So the Cloud SQL is basically a relational database type and it supports MySQL, PostgreSQL, and Microsoft SQL Server. Who can use this Cloud SQL? The traditional web applications and the business applications or the legacy applications can go and use the Cloud SQL. Okay, the Google Cloud BigTable, that is basically NoSQL database type and it's a column oriented, right? So it can scale up to thousands of columns. And the big data and machine learning workloads we can perform using this BigTable. Then there is a Cloud Spanner, which is basically RDBMS plus NoSQL, because it can be launched many different geographical regions and it can be easily scaled. So you can use it for the application which is distributed globally. Then there is a Cloud Memorystore, that is basically in memory DB type and it has low latency Redis cache, right? You can use this application wherever there is a frequent retrieval of data. In that cases you can go and use Cloud Memorystore. Okay, so that's all about this section. If you are not subscribed to this channel yet, I request you to please go and subscribe so that it will give us the motivation to make more videos like this. Thanks for watching. See you in the next section.